Hi, I'm Scott Evans, and today I'd like to talk to you a little bit about measuring impulse response and doing time alignment of speakers. A little background about me: I'm a professional audio engineer, have been in the entertainment industry for over 25 years now. I've done everything from small little band in the corner of your favorite local bar to large arenas to big stadium tours with some of your favorite bands. I also have done installs in home theaters, movie theaters, recording studios, sporting venues, concert venues, and a lot of other little places as well. Today I'm going to show you how to do the impulse alignment in 3 different softwares. We're going to use AFMG Systune, which is my personal favorite and the one I use the most commonly, Smaart, and I'm going to use version 7, which is made by Rational Acoustics, and REW, which is popular amongst the DIY crowd. Just to give you a quick view of the test rig that was used for these tests, I have a double 18 JBL loaded subwoofer box with 2242s in it. I have a double 15 1-inch horn box that is also loaded with JBL drivers. We're using a Marantz preamp, some BSS SoundWeb processors. Amplifiers were Lab Group and FP 10000Q for the mid-range and high-range, and a Yamaha T5N for the subs. This was all processed using a USB Pre 2 from Sound Devices, and all measurements were made with a DPA Type 4007 reference microphone. Before we get started on actually measuring things, I just wanted to show you we set all of our delays for the low, mid, and high drivers to 0 so that we had an even start to begin with. Before we get too far into measurements, I just wanted to talk first about how we do the measurements to begin with. Generally, we start with a signal generator of some kind, typically pink noise, and then we send that signal out of our computer through the hardware we're testing, and then we listen to it back through a microphone or through a direct line in, back to our preamp, and then software analyzes this, and then we can use that to look at the impulse response, the phase, the frequency response, various things that we can look at using our computer. And we're going to do that with multiple softwares here in this example. Okay, the first thing we're going to do is we're going to take some measurements using our hardware, because we need to know if there's any delay built into the system, and we need to make sure all the outputs are functioning correctly to begin with. We're going to do this. We're going to start with the AFMG Systune software. You can find this software for 650 euros on their website, which is approximately $760 US at the time this video was made. So to do this, what we do is we take our signal, which in this case is pink noise, and we send it in through our Marantz preamp and then into our BSS SoundWeb processors. And we take that out of the outputs of that directly back into the preamp to measure, and from that we can see a hardware impulse time. We can see just how much time it takes to actually make its way through all the processing. This particular screen you're looking at, the top section, top center section, is the impulse response itself. That's what we're looking for. This hump in the signal, this where we see this spike, is what we're trying to find, and we want to find the center of that spike to be able to measure it, and that is our impulse response. The bottom window of this is the phase response, and phase response correlates to the crossover, the EQ, any delay that's built in. Many things can affect the phase response of the system. In general, your direct signal, if you have no processing, should respond completely flat through the entire processing range. With this particular output, we're looking at a subwoofer output, so it's only going to be flat within the subwoofer range between 0 and 85 hertz. And it may not be perfect because of processing that I have going on. So it's roughly what it should look like. A crossover will always shift the phase at the crossover point. An EQ will always shift the phase around the point where you do the EQ at. On the upper left-hand side of this screen, you'll see some numbers. There's a section where it says calibrate, and then there's a peak and an auto, and directly above that is the number 6.557. That number relates to the time of our impulse. I can click that peak button, and it will automatically find the impulse and move it to 0 for us and tell us how much delay time it takes to get to that. In this case, the subwoofer output takes 6.557 milliseconds of time to get through the system and back to our measurement device. So that is my impulse response. I do this with all my outputs, so I have a good starting point. My mid-range output, I had to zoom in a little bit to see the peak better, to find where the center was. But when I look at it, that time turns into 3.932 seconds, right? So it's a little bit faster going through the mid-range processing than it is going through the sub-processing. Because of that, that means that we're going to be adding time to our mid-range to make it line up with the subs. And you can see the phase response through the mid-range. There's very little correction going on. There is an FIR filter on it. At the high end of it, the range is 85 to 1.6K. And so at the 1.6K point, there is an FIR filter that corrects the phase through the crossover point to help smooth that out some. The high end, we do the exact same test. I have to zoom in a lot closer because on high end, your wavelengths are very, very narrow compared to subs, which are very, very large. And so because of that, I have to zoom in a little further to see it. And it's not as smooth of a graphic when I look at it. I can see from this, the delay time is 3.765. Again, we'll be adding time to it to line up with the subs. This just gives us a good ballpark starting point for how much we need. The phase trace looks reasonably flat, so I know I'm in the right ballpark with that as well. Okay, so now let's start looking at the measurements of things now that we have a hardware measurement. So now we've got a microphone set up. It's roughly 7 to 8 feet away from my speakers. I've got some heavy things hung behind it to help cut down on some reflections that we might get from the room. I probably have some, and you're going to see some in the graphs that show. So when I do my first measurement, I'm going to measure the subwoofer again. And this time, when I look at my delay time, it shows 15.953. So that to me makes sense. It's somewhere in the right neighborhood for the distance that I have. And potentially the driver response is a little bit slower because it is a big heavy 18 compared to a little tiny tweeter. So I expect it to be somewhere in the neighborhood of 8 to 10 milliseconds longer than my initial hardware measurement. So I feel pretty good about this, that this is correct. You'll notice slightly to the right there, there's a second hump, there's a second peak, and that second peak happens somewhere around 28 to 30 milliseconds. Well, it just so happens that my room is roughly 30 feet deep that this was done in, so I'm probably seeing the reflection of the subwoofer off the back wall on this because low end travels through things pretty easily, and what I have hanging is really just a thick blanket, and so it's probably not blocking any of that subwoofer at all. So I'm seeing a reflection there. My phase response is relatively flat at this point, so that tells me that my 15.953 is probably pretty accurate for the number to start with. When I'm doing measurements now that I know what my hardware measurements are, I'm no longer going to move my delay time. So that 15.953 number is going to stay fixed for the remainder of my tests because I know that this driver should be the one that already has the longest delay built in, and I need to add delay to my other speakers, my other drivers. Right? So we will no longer move that. When I look at my mid-range, I can see that it's somewhere between the 0 and 10 there. So it looks like it's right in the middle. It's about 5 milliseconds-ish. I didn't have the mouse cursor moused over it properly, but I could have put my cursor over it and I could find the exact number. And I could see that it's roughly 5.2 milliseconds. So all I've done is use the same delay time as my calibrated time at 15.953, and I've looked at that microphone, and the microphone has now said that this number is different, therefore it is not going to land on 0. My phase won't look correct because I'm not at the correct spot reading the impulse. I'm not on the impulse peak reading it. So my phase is useless at this point until I get the impulse response back in line. So I go into my software and in my processing, and I add a little bit of delay to it. And I just slowly move it till it gets close. I know I can start around that 5 millisecond range, and then I can just cursor up and down until I get it in line. And by doing that, and I zoom in a little bit on this picture to get a better picture of the peak, I can see that it centers up here. And when I'm centered up, I'm at 5.145, right? I'm going to try to keep this in reasonably small amount of decimals, but I'm at basically 5.145 milliseconds. And my phase response, you can see through the crossover range that it looks relatively correct, right? From 100 to 1.6, it's pretty much in the middle. It goes up at the low crossover and comes down at the high crossover, just as I would expect. All right, and then we do the same thing for the high end. So my delay time's still set at 15.953. I haven't touched it. Again, I'm moving it physically within my software for my processing, or I'm physically moving the speaker itself, depending on what I'm measuring and what I'm doing. This one I look at, and I'm somewhere around 4.5 milliseconds out, and I put my mouse cursor over it to show it as well. So you can see there, 4.52 milliseconds is the difference that I need to move this. So I go into my software, I add my 4.5 milliseconds, zoom in a little bit so I can see the peak better, and lo and behold, on the money at 0. My phase response looks great. Looks like I'm relatively around the 0 point. Again, it's never going to be perfectly flat. It'll be close. That gets me in the right spot. And I can see that on that I've got a couple other little peaks. Those other little peaks are reflections from something. Just gives me some things that I can look at later, so that if I want to do some room correction and I want to put up some panels for absorption, I can use those extra peaks to help me figure out where that's at. Okay, the next piece of software we're going to look at is Rational Acoustics Smaart, spelled S-M-A-A-R-T. Rational Acoustics website has the software listed as version 8, and it retails for $995 US. I will currently be demonstrating this in version 7 because that is the version that I own, and I haven't upgraded to version 8. With Smaart, we do a similar process where we measure and try to find our impulse response, and they have a whole separate page just for the impulse response, so it's easier to look at. Looking at this, we get the same kind of function. We tell it to start, we get some samples from it, and then it does some calculations, and then it spits out, just like everything else does. And we can see the same shape of the graphic just like we did in the other software. And it shows that it lands right around 16 milliseconds, right? So we're in the same ballpark as we were on Systune. On the right-hand side of this window, you'll see a section there that says group pair FFT. The FFT we're using for this is the same 32K. We're using pink noise once again, and the pink noise is also pseudo-random at the FFT range of 32K, meaning that it starts and stops its generation and then repeats. The button at the very bottom of this window says peak to delay. That button right there is the easy way of getting your number into the real-time measurement section of this software. You just click it and it does the work and puts you in the right spot. When I click that, it shows up as 16.04. The reason that I do subs in the impulse response section instead of in the real-time section on this particular software is because this particular software isn't as good at doing subs real-time for the impulse response. You can still see the phase response just fine, but it's very, very hard to look at the actual impulse response in the small window that's up top for the way that it picks it up and the way that it responds. So I always have to do it in that impulse response section first and then copy over to make sure I've got the right amount. Looking at this, we can see that our phase response through the crossover does a similar thing that we did in Systune, so we're good to go. We're going to do the same measurements on the mid-range and the high range and move them just the same way. So when we look at the mid-range, Now we can see in that window, we've got enough resolution there. We can see that spike that we saw in the previous software. And we can look at it and see that it's approximately 5 milliseconds off, which seems to make sense with our other measurements as well. And then we know from that we need to move it in our BSS software. We need to move the delay time just like we did previously. So I start out by adding the 5, and then I move it a little bit at a time until I get it centered over. And what I find is to get it centered over, I end up back at that 5.14 that we had in the first software as well. Phase response looks reasonably flat across the whole range. We're good to go. When I do the high end, again, same problem where very, very small frequencies or very, very high frequencies make very, very small wavelengths. So we have to zoom way in to see it. So I lose a little bit of resolution on my graphing. And I can see here when I put the mouse over it, it tells me 4.5 milliseconds. So, and that's right at the number that we were seeing before in Systune as well. So we know that this should be the correct amount. When I move it to 4.5 milliseconds, it happens to line right back up again at the 16.04, just like we're seeing. And we can see our phase response again is reasonably flat through the entire range that it's used. One of the things you can look at and notice is that the numbers seem to match reasonably close as well on the distances. The 16.04 is the same kind of distance that we got with Systune for the microphone measurement. We haven't changed anything on that, so we know that that number is correct. The third software we're going to look at is REW. REW is completely free, no charge. You can download it from the internet. Look it up on Google if you need to find a link. REW is very popular amongst the DIY crowd because of it being free. In REW, measurements are done by making sine wave sweeps and then looking at the data, making some changes, doing more sine wave sweeps, looking at the data, doing more changes. It is not real time. You are doing it in a measure, look, change, measure, look, change kind of method. So it is a bit slower to use because of this, but can still get the job done. One thing I have found is that REW is not very good at a certain calculation for the impulse response, and I will show you that here as we go. So I did measurements first, and I went through and did all 3 just like I did in every other software. And then once I did my 3 measurements of sweeps, I went into the controls button, which is the upper right-hand corner of this window. It says controls, and you click on that and a little window pops down, and in the lower left-hand corner of the pop-down is estimated IR delay, which is kind of grayed out there. You can't really see it, but when you click it, it shows delay estimation complete, and it gives you a number. In this case, it's telling me 8.371, which is drastically different than my other 2 softwares. So at this point, I don't know whether to believe this number or whether to count it as garbage, but currently it does not make sense for what we've seen in the previous softwares. And I'll be able to show you how we can verify this as well. When I look at the mid-range driver, 10.5, right? So that seems pretty close. 10.501 is roughly the same line. We were at 10.8 roughly on the other 2, so 10.5 is believable. It's still not 100% correct, but it's believable. It's closer. When I look at the high end, 11.3, so our measurements on the other ones were 11.4. So we're in the same ballpark there, and we at least have a starting point, right? We have measurements, and that's the point. So I wouldn't use this estimate IR delay as truth right now. The numbers don't line up with what I previously mentioned. You should be aware of this if you're using this software, that the estimate IR delay is probably incorrect. So the way to do it is now to look at the visual of the graph just the same as we did previously, right? Find the center of it, put your mouse over it, and then you can see what it's doing. 16.15 at the bottom, right? Well, this seems to make more sense as everything else was around 16 milliseconds. So 16.15 is a believable number to me, right? I'm going to count that as my sub. Why it said it was 8 something, I have no idea. But I can look at it this way and see it. And I can also see that second hump. When you're looking at this, you'll notice on the left-hand corner of the window there, it says %FS. That's very important. The default is in ETC mode, which will be multiple humps, and you won't be able to judge polarity from this. Polarity is important. If the hump goes up, polarity is positive. If the hump goes down, polarity is negative, and you need the polarity to be identical when you align things. So if you're doing multiple subs, both subs need to have a positive polarity, or both subs need to have a negative polarity, depending on your system. 99% of the time, we want everything to have a positive polarity. There are circumstances to use things in a negative polarity, but 99% of the time we want positive polarity. Whether it means you flip a button on your speaker, or whether you physically flip wires, or whether you change a setting in software, make sure that the output you receive here shows a positive polarity, a hump going upwards. Again, we see that second hump just like we did before because of the reflection on my back wall. Nothing changed between tests other than the software. When I look at my mid-range, I can see that it's at 10.8. Again, a believable number when I center over it. When I look at my high end, I can see 11.4. Again, a believable number when I hover over it. It's relatively close. It seems to fall in line with my measurements. All right, so the next step is to do just as we did before. We're going to start with our subwoofer and do a measurement and make sure it's still there, still at the 16.04 in this case is where we centered on when we do our measurement. And we're going to make everything else move to it. So we add a little bit of delay time into our speakers, and then we measure again. And then we look at it again. And then if it's not sitting on 16.04, then we move it a little more, we do some math, and we try to figure out how far we have to move it. I can actually do physical math and move it. I can look at this and see that that 10.08 needs to move 5 and some change to get back to me, to get where it needs to be, right? 5.2 gets me up to 16.0. So I move it that 5.14, and again, it lines up with me. It falls right in line if I do that, right? There we go. So there's the mid-range. If I move it the right amount, keep the line at 16.04, I can see that that now lines up. So now those two have been aligned. I can do the same thing with the high end. I can zoom in, I can find that peak, and with that peak, I can see that I'm at 16.04 again. I had to add 4.5 milliseconds just like before. The math told me 16.0 minus 11.3, it gets me in that 4.5 range to start. I can find it. I have to do multiple tests to get there, and it takes a little bit of time, but I can still get back to the same result. So I've added the exact same thing as I have in all my other software. One thing that isn't great to look at in REW is the phase response. The phase response is not great. It's not going to tell you much information. I don't know what they're doing with their minimum phase calculation, but it's not very useful to look at, and it's hard to quantify if you don't understand what you're looking for as well. Again, we're looking for a relatively flat response through the crossover range that we're using, and in this case, it's got a pretty bad skew to it, and I can't quite tell if that's correct or not. My mid-range does a similar thing as what it did in the other softwares, and my high-end does a similar thing with the exception that it seems to carry flatter in this out past my past the top, which is just a matter of how they're doing the calculations in this. So I wouldn't trust too much in the phase. It's okay to look at and just kind of make sure you're in the ballpark with it, but I don't trust the phase response too much with this. In general, being free software means that it's going to have some things that it doesn't do as well as paid software. So keep that in mind as well. Once again, thank you for watching. You've been watching the impulse and time alignment video that I've made. Here at the end, I'm going to give you just a little bit of extras. I'll give you some different sounds that we talked about in this. The pink noise we've got randomly generated that generates to infinity, never the same ever. We've got pink noise that is pseudo-random, which is what we like to use because we can match it to the FFT size, which helps with keeping our data cleaner and giving us a better noise floor to work with. The Sine Sweeps, I'll give you one in 512 FFT and one in a 216 FFT, which is the stuff that REW uses. So you can hear the differences between them and maybe have a little bit more understanding of what they sound like. Once again, thanks for watching, and I hope this has helped you out somehow.